Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, data flow. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: what is a Power BI data flow, and why is it used in Power BI architecture? A Power BI data flow is a cloud-based ETL, extract, transform, load solution that allows users to ingest, clean, transform, and store data centrally in the Power BI service. It uses Power Query Online to perform transformations and saves the transformed data into Azure Data Lake storage as CDM, Common Data Model, compliant folders. Data flows are used to standardize and centralize data preparation, ensuring that all reports and datasets use the same cleaned and validated data sources. They improve scalability and governance by offloading heavy data transformation from Power BI Desktop to the Power BI service, which reduces refresh load and enhances reusability. Second question: how are data flows different from Power BI datasets? A data flow is responsible for data transformation and storage, whereas a dataset focuses on data modeling, relationships, measures, and visuals. Data flows act as the ETL layer, while datasets act as the semantic layer. For example, a data flow may prepare a customer table with cleaned phone numbers and merged addresses, while a dataset uses that table to create relationships and DAX measures. Multiple datasets can consume the same data flow, promoting reusability, but a dataset is typically used by a single report or a set of related reports. Data flows store data in Azure Data Lake in CDM format, whereas datasets store data in the in-memory VertiPack engine for faster query performance. Third question: what is the role of Power Query Online in Power BI data flows? Power Query Online provides the interface and engine used to create, edit, and run transformations within data flows directly in the Power BI service. It allows users to perform the same data cleansing and shaping operations available in Power BI Desktop, such as merging, filtering, grouping, and custom column creation. Power Query Online runs transformations in the cloud, meaning all processing happens in the service rather than on the user's local machine, which improves performance and consistency. It ensures that transformations are centrally maintained, versioned, and governed, reducing duplication of logic across multiple Power BI desktop files. Fourth question: what are entities in data flows, and how do they relate to the Common Data Model, CDM? Entities are the tables created within a data flow, each containing columns and transformed data similar to tables inside Power BI Desktop's model. Each entity represents a standardized business object, such as customers, products, orders, or employees, and can be reused across multiple datasets and reports. When data flows are saved, entities are stored in Azure Data Lake using the CDM folder format, making the data accessible for integration with other Azure services. CDM provides a consistent schema and metadata structure so that entities follow a predictable and well-defined format, which improves interoperability and maintainability. Fifth question: what advantages do data flows offer over performing all transformations in Power BI Desktop? Data flows centralize transformation logic in the cloud, ensuring all datasets and reports use consistent, governed, and standardized data rather than duplicating Power Query steps in multiple PBIX files. They offload heavy transformations from Power BI desktop and personal machines to the Power BI service, reducing refresh times and improving performance for enterprise-scale datasets. Dataflows support reusability, as the same dimension or fact table, example a date table or customer master, can be consumed by multiple datasets and workspaces without recreating it. They enable scheduled automated refreshes, dependency management, and reduce load on source systems because the transformed data is stored in Azure Data Lake and not repeatedly queried at the source. Sixth question: what are linked entities in Dataflows, and when should they be used? A linked entity is a reference to an existing entity from another dataflow, allowing you to reuse the same table without duplicating data or transformation logic. Linked entities help maintain a single source of truth, ensuring that all dependent data flows and datasets pull data from the same standardized tables. They are ideal when multiple data flows require access to the same dimension table, such as a date table, customer master, or product hierarchy. Linked entities improve governance and consistency because changes made to the source entity automatically propagate to all linked entities. Seventh question: what are computed entities, and how do they differ from linked entities? A computed entity is created by applying additional transformations on top of a linked entity, and the output is processed using the enhanced compute engine. Unlike linked entities, computed entities store their own data after transformations, which allows resource-intensive logic to run once and be reused. Computed entities are beneficial for preparing intermediate layers in a multi-step ETL process, such as creating aggregated or denormalized fact tables. The key difference is that linked entities simply reference the original data, while computed entities generate and store a transformed physical table in the dataflow. Eighth question: what is the enhanced compute engine in Dataflows, and how does it improve performance? The enhanced compute engine is an in-memory SQL-based engine that accelerates data transformations and improves refresh performance for computed entities. It supports optimized query execution, enabling faster joins, filters, aggregations, and merge operations that would otherwise take longer using only Power Query. When enabled, the engine stores data in a columnar format, allowing subsequent transformations to use high-performance SQL queries instead of M-engine row processing. It significantly reduces refresh time in complex ETL pipelines, especially when working with large tables or multiple dependent entities. Ninth question: how does incremental refresh work in a dataflow, and how is it configured? Incremental refresh loads only the new or changed data during each refresh instead of reloading the entire dataset, which improves performance for large tables. In a dataflow, incremental refresh is configured using parameters such as range start and range end to define which portion of data to refresh. Users specify the retention period, example keep 5 years of data, and the incremental period, example refresh last 1 month, allowing historical data to remain untouched. This feature reduces refresh time, lowers resource consumption, and minimizes impact on source systems like SQL databases. 10th question: how do you schedule and manage dataflow refreshes in Power BI service? Refresh schedules can be configured directly in the Dataflow settings, allowing daily, hourly, or multiple refreshes as per business requirements. The Power BI service allows multiple refresh slots based on the workspace capacity. Premium allows more frequent refreshes than shared capacity. Refresh history and logs are available for monitoring failures or performance issues, helping users troubleshoot errors. Dependencies between data flows can be managed by setting refresh order or using computed entities to ensure the correct sequence. 11th question. What types of data sources are supported by Power BI Dataflows? Power BI Dataflows support a wide range of sources, including Azure SQL, SQL Server, Oracle, SAP, Salesforce, SharePoint, Excel, CSV, and many more cloud-based and on-premises systems. They use Power Query connectors similar to Power BI Desktop, ensuring consistency in connectivity across both environments. Gateways can be used to connect to on-premises sources, enabling secure data extraction from internal systems. Most major enterprise systems are supported, making data flows flexible and suitable for multi-source data ingestion scenarios. 12th question. What is the impact of enabling or disabling load enabled in data flows? When load enabled is turned on, the entity is loaded and stored in the Azure Data Lake as part of the data flow output. Disabling load enabled prevents the entity from being stored but still allows it to be used internally within the data flow for intermediate calculations. This option is useful for creating intermediate steps or helper queries that support transformations but do not need to be exposed externally. Turning off load for unnecessary entities improves refresh performance and reduces storage consumption in the data flow. 13th question. How does query folding work in data flows, and why is it critical for performance? Query folding is the process of pushing data transformations back to the source system, allowing SQL systems or cloud sources to perform the heavy computations. It improves performance because large joins, filters, or aggregations are handled by the database engine instead of the Power BI Dataflow engine. Folding reduces data movement across the network since only processed results are returned instead of entire raw tables. It is essential for scalable data flows because non-folding steps force Power Query to handle transformations in memory, slowing refresh time significantly. 14th question. What common transformations break query folding in Power BI Dataflows? Transformations like adding index columns, referencing another query, or using custom M functions often break query folding. Non-native operations such as changing column types multiple times or performing row-level operations, example, add custom column, may prevent folding. Merging tables from different sources or applying complex transformations like pivot or unpivot also commonly disrupt query folding. Once folding is broken, all subsequent steps run locally, significantly reducing performance for large datasets. 15th question. How do data flows reduce load on transactional systems like SQL Server or ERP systems? Data flows extract and transform data once and store it in Azure Data Lake, preventing repeated queries to transactional systems during report refreshes. Incremental refresh further minimizes load by querying only recent changes instead of pulling complete tables each time. By centralizing ETL in Power BI service, data flows prevent multiple report creators from independently querying the same SQL or ERP tables. Cached and optimized entities serve as a reusable data layer, reducing strain on source systems and improving overall system stability. 16th question. How are data flows stored internally? Explain the architecture. Power BI Dataflows store their output in Azure Data Lake Storage, ADLS, Gen 2, where each entity is saved as a set of CSV files along with JSON metadata files. These files follow the Common Data Model (CDM) format, which includes a model, JSON file defining schema, data types, relationships, and descriptive metadata for each entity. When a data flow refreshes, the Power Query Engine writes the transformed data into ADLS, creating optimized CDM folders that can be consumed by datasets or other Azure services. This architecture enables interoperability with Azure Data Factory, Databricks, and other tools, making data flows suitable for enterprise-wide data integration. 17th question. How do you reuse a dimension table across multiple reports using a data flow? You first create a data flow that contains the cleaned, standardized dimension table, example date, customer, product, as an entity within the data flow. In Power BI Desktop, instead of importing the source directly, multiple datasets connect to this dataflow entity using Power BI Dataflows connector, ensuring consistency across reports. This design eliminates duplication of transformation logic across different PBIX files, making maintenance easier and ensuring a single version of truth. Any updates made to the data flow automatically reflect across all datasets and reports that depend on it, improving governance and scalability. 18th question. What is the dependency chain between multiple data flows, and how do you control refresh order? When one data flow uses another data flow's entity as a source, via linked or computed entities, a dependency chain is created where downstream data flows depend on upstream ones. To maintain data accuracy, upstream data flows must refresh first, example dimension data flow, then staging data flow, then fact data flow. Power BI Service allows you to define refresh order manually by scheduling dependent data flows at staggered times or using dependencies configured within the workspace. For complex pipelines, computed entities automatically manage the dependency chain because they trigger refreshes based on upstream changes, ensuring proper sequence. 19th question. What are the limitations of Power BI Dataflows, Gen 1? Dataflows General 1 are not designed for heavy enterprise-scale ETL workloads, and their performance can degrade when managing extremely large transformations or multiple complex entity dependencies. The storage format, CDM folders using CSV or JSON files, is less efficient for incremental or iterative processing, causing refresh operations to become slower as data volume grows. There is limited governance and lifecycle management, meaning you cannot implement features like version history, environment branching, automated testing, or advanced monitoring natively. They do not support direct application of row-level security or model-level permissions. Because data flows only prepare data, the actual security layer must be managed at the dataset level. 20th question. How does RLS, row-level security, relate to data flows, and where should RLS be applied? Power BI Dataflows do not support RLS because they serve as the data preparation layer, not the semantic or security layer. RLS must be applied at the dataset level, where relationships, roles, and DAX filters are defined to control what data each user can see. Even if a data flow contains sensitive data, filtering or restricting access must be implemented in the dataset model or reports that consume the data. Data flows should remain accessible to data engineers and model creators, while the dataset enforces user-specific access through properly configured RLS roles. 21st question. A data flow refresh succeeds, but the dataset refresh fails. What steps would you take to diagnose the issue? I would first check the dataset's data source credentials in the Power BI service, because Dataflow Refresh uses its own credential store, while datasets use a separate one, which might be expired or missing. I would review the dataset refresh history to identify whether the failure is due to schema changes, missing columns, or data type mismatches introduced by the dataflow. I would verify whether the Dataflow workspace permissions allow the dataset to access the linked entities, as insufficient permissions can cause the dataset refresh to fail. I would inspect the gateway configuration if the dataset connects to other sources besides the dataflow, as a misconfigured or offline gateway may break the dataset refresh while the dataflow continues to work. 22nd question. Your dataflow refresh time increased from 15 minutes to 2 hours. How do you troubleshoot performance issues? I would review whether query folding has been broken due to added transformations, because losing folding pushes all processing to the Dataflow engine and drastically increases refresh time. I would check for new data volume spikes in the source system, especially in transactional tables that have grown significantly since earlier refreshes. I would examine whether computed entities or linked entities are causing chained refreshes or circular dependencies that force the engine to reprocess multiple tables. I would analyze whether any joins, mergers, or data type conversions have been modified recently, since inefficient transformations or mismatched keys can slow down the refresh pipeline. 23rd question. You need to combine data from SQL Server, Excel, and SharePoint. How would you design a data flow for this scenario? I would create separate staging entities for each source, SQL Server, Excel, and SharePoint, to isolate extraction logic and avoid mixing raw and transformed data. I would ensure that data types and column names are standardized across these staging entities so that downstream merge operations remain clean and reliable. I would create a transformation layer entity, computed entity or normal entity, that merges or appends the standardized data from each source to produce the final unified table. I would configure the refresh schedule so that the staging entities refresh first, followed by the transformation entity, ensuring proper dependency order. 24th question. You want the data flow to maintain a slowly changing dimension, SCD. How would you implement this? I would create a historic dimension entity that stores all past versions of the records, including surrogate keys, valid from dates, and valid to dates. I would create a staging entity that loads the latest snapshot from the source and identifies changes by comparing business keys and attribute values with the historic entity. I would implement logic in Power Query to generate new rows for changed records while closing previous rows with an updated valid to date. I would use incremental refresh on the SCD entity whenever possible to keep processing efficient and avoid reloading the entire table every time. 25th question. You must promote a data flow from dev then test then prod. What is the recommended process? I would export the data flow from the dev workspace using the JSON definition, dataflow, JSON file, ensuring that all entities and transformations are captured. I would import this JSON into the test workspace and update environment-specific parameters, such as connection strings, credentials, or relative file paths. After validating the output in test, I would repeat the same import process into prod and configure refresh schedules, parameters, and credentials appropriately. I would maintain workspace level separation to ensure clean promotion flow and prevent accidental overwrites or cross-environment contamination. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.